The drive to deliver power solutions at ever greater efficiencies has increased the need for measurement accuracy. Today, we are going to look at two oscilloscopes, a Tektronix MSO 4104B and an Agilent MSO X 3104A. We will examine where you are likely to encounter power measurement errors and demonstrate the superior performance of the Tektronix MSO 4104B in helping prevent you from making those errors. One source of error can occur when measuring small currents with a probe that does not have enough sensitivity. In this example, we're measuring a 5 milliamp signal using a Tektronix MSO 4104B and a TCP0030 current probe, which is capable of making measurements down to hundreds of microamps. On a 5 milliamp signal, it not only produces an accurate amplitude result of 5.04 milliamp, but the finer details of the waveform can be easily observed in sample mode, high-res mode, and average mode. We'll now consider the same measurement using the Agilent oscilloscope and the 1147A current probe, which is the current probe with the highest sensitivity referenced on the MSO X 3104A datasheet. Notice that we're having difficulty triggering on the signal, and you may also notice that the finest vertical axis resolution available using the Agilent products is 10 milliamps per div, as opposed to the much finer 1 milliamp per div for the Tektronix oscilloscope. Now notice the amplitude measurement readout on the Agilent for the 5 milliamp signal. It is displaying 13 milliamp, which is 2.5 times the actual amplitude of the signal. And the finer details of the waveform cannot be easily observed whether in the sample mode, high-res mode, or average mode. The TCP0030 has 10 times the sensitivity, over twice the bandwidth, and nearly 3 times the dynamic range of the 1147A. Another source of error in current measurements occurs when the probe is driven beyond its input range. For example, a transient event can overdrive the probe, which may saturate the core and cause a measurement offset due to the residual magnetism in the core. Knowing the probe has been overdriven is important so that you can take action to ensure that subsequent measurements are not affected. Here we see displayed on the Tektronix MSO 4104B an example of what happens when the TCP0030 experiences an overload condition. There is a visual indication on the probe, compensation box, and oscilloscope that clearly alerts the user that an overload condition is occurring or has occurred. When an event such as an overload has saturated the core, a degauss operation is required. The TCP0030 not only provides an overload indicator, but it also provides a visual indicator that a degauss operation is also necessary. When the Agilent current probe and oscilloscope are connected to the same overload signal, we can see that there is not visual feedback indicating that an overload condition occurred, nor is there any indication that a degauss operation may be necessary. This could lead to subsequent inaccurate measurements as troubleshooting continues. Also important is the ability to know when the jaw of the current probe is fully locked. If not properly locked, the current measurement will be inaccurate. The MSO 4104B measurement system provides an indicator that tells users if the jaw is open. The Agilent MSO X 3104A system does not provide that same active feedback, which could lead to user frustration. You have just seen a few examples of why it is important to pick the right oscilloscope and probe combination to accurately make current measurements you need. The Tektronix MSO 4104B is compatible with a wide variety of current and voltage probes for all of your evolving power measurement needs.